Hi everyone, welcome to Biomechanics. Today's lecture is going to cover some introductory information, give you an overview or a scope, and then it's going to set you up a little bit for some prerequisite math information that you'll need. But again, I just want to try to set up a good perspective or paradigm as far as approaching the class and approaching the math aspects of the class, and then give you an opportunity to go ahead and practice some of that. So let's dive into things. So just to give you an idea, of starting off with what it is we're looking at in this class is kind of this intersection between biology, our biological selves, and the mechanics or the physics aspect of the world around us. Now, as you can imagine, in sport and human movement, the way the physical world works around us really applies to everything we do. It's a constant, right? So understanding that and the interactions with our body is paramount to understanding movement and how we move in the world. But of great interest also with biomechanics is this concept or this idea of how do we take things such as like sporting performance or just generally moving around as humans, how do we take that and make it the most efficient that we can? How do we take that and make ourselves the most effective at our goals that we're trying to achieve with our movement? Or how do we prevent injury? So I have a little picture here of actually a bike race with my cycling team here, and this is a big sprint to kind of the finish here. So much is happening as far as the physics that can be applied to this particular scenario, and towards the end of the course you're going to be able to identify a lot of those concepts and apply them, and ideally take that into whatever career you happen to be in within the movement specialist realm. So whether that's coaching or kinesiology, physio, whatever it happens to be. Okay. So let's take a look here. Again, just kind of a bit of a definition, but more or less what I've already covered. Biomechanics is the study of structure and function of biological systems by means of mechanics. So again, the mechanics is ultimately just the physics of the world that we work in. Okay. As far as, and I've had a few questions about this, as far as the amount of anatomy that you'll need to know, it's not too great relative. So for example, you're not going to be expected to know all of the detailed anatomy that you would learn in your anatomy and physiology classes, but having a working understanding is going to be important. Some general ideas as far as once we get into a bit more of the application stuff late in the semester. So just having a working idea is good. But that being said, we will be focusing a lot on the physics aspect and the math aspect and calculating and figuring out how to use equations, because that's one of the more challenging aspects. Once those concepts and that skill set is built up, it's easier to introduce the physiological or the anatomy aspect into it. But one thing I definitely want to say, and I'll scooch back actually for this component, if you don't know much about cycling, and I'm using cycling as an example, and that doesn't make any sense to you, like you don't know what it means to be in a sprint finish in a bike exactly when you're applying force or torque around, say, to use terminology like the crank. If you don't know what that is, feel free to ask them. I'm more than willing to try to find a different sport for an example or something like that. Okay. So again, as I mentioned, one of the big points of biomechanics is to, first of all, improve performance, and secondly, to decrease or prevent injury or the risk of injury. Now, that's, again, applying and looking at the intersection between our biological systems and our mechanics. And again, we'll focus a lot on the mechanics aspect, a little bit less on the biological as a whole, but integrate the two throughout our course. There's two main divisions in biomechanics, and we actually have our semester split up this way. So the first half, or the first portion up to the midterm, looks at something called kinematics. So we're describing motion, describing movement, describing physics without the use of force. Okay, so force is a very specific concept, and we're going to save that for the second half of the semester under the topic of kinetics. Okay, so when we're talking about variables and describing motion without the use of force, what we're really talking about are variables such as time, the position of something, the displacement, which is related, velocity of something, acceleration. These are all concepts that help explain the what about a motion. Okay, kinetics, on the other hand, is more about the forces. So when I apply a certain force, it has a mass and acceleration. We'll get into that, but ultimately those have its own ties and variables and aspects of physics that we look at. They're not completely separate from one another. There are concepts that overlay, and certainly kinematics and understanding that will give a better foundation for when we go to look at kinetics. But again, they're two separate different fields. Okay. And the kinetics again explains why. If something's moving, we can describe that with kinematics. But when we look at kinetics, if we want to explain why is something moving, we have to explain the forces involved. Okay, so you can kind of set up a bit of a structure in your mind as to how we'll be exploring the course that way. Now, once we get to the principles of math, I know there might be a little bit of concern, especially, if you've taken a physics course before. A lot of the times courses rely on calculus. We won't be using that here. However, you do need to know how to convert units very readily. Using algebra to solve for an unknown variable, definitely a valuable skill and tool to have. Similarly, we come across trigonometry as well as incorporating some use of sine and cosine and stuff. If all of that is sounding very distant or unfamiliar at this moment, don't worry, fret not. As long as you're setting aside a little bit of time, if you haven't developed the skills for math yet, that's good. If all this kind of content as we're going through it doesn't resonate right away, please don't be discouraged. It takes time to build up skill and understand the rules of math, so it will take making mistakes, and it will take making errors, and that's okay. In fact, I expect that from most students. It's typically when I hear nothing and there's and students don't even try, even though they're getting stuck in not getting it. That's where students end up not succeeding. Okay, so the success comes in the effort and the time that you put into learning these skills and rules involved with math. My favorite thing to bring up with students is when you look around you, and we do this, we're social human creatures as humans, so we like to socially compare. So if you're looking around at your peers and they just seem to be getting this, like it's super easy, etc., I really don't get discouraged. I mean, ultimately, at the end of the day, these students have just put time into learning how to do math at some different point in time in their lives. So the fact is, if you haven't done that yet in your life, that's fine. Just expect to, if you want to be successful with this aspect of the course, that you'll need to put in a bit of time for that. Okay. Yeah, there's no magic with math. It's just learning the rules, right? Okay. So speaking of which, let's take a little look here at some units and unit conversion. Okay. there's some examples here, and you can always use, since you're at home, you can just use Google and use a calculator there to double check the answers, because we're not going to go through all of them, but we'll go through a few of them and just get some grounding and basis in what we're doing here with unit conversion. Okay. So first up, let's take a look at question 1. Okay. And generally speaking, anything we do, especially in this course, is going to be in the metric system. In particular, as we'll come to learn, each equation or variables or concept that we come across will require something called an SI unit. And that's just like a standard international unit. And it just helps, again, literally standardize everything. So when we come across concepts, you'll see a unit associated with that variable. That's going to be good to know, okay? But let's just let's take a little look here at our first conversion question, number 1. How many kilograms is in, what is that, 20,000 grams? Yeah. Okay, so let's see how we can do this. Again, there's 2 different ways that we can approach this. One is we can write out 20,000 grams, and we know if we're trying to work to kilograms, we use that little tool that we're taught in school, where we can go 1, 2, 3 over, move the decimal place over, and we can arrive at the conclusion that we have 20 grams. That's great. But to do it a little bit more in a way that will help build skills for us to use math and convert across multiple units if need be, a really good skill is to be able to take a conversion factor and use that. Okay, so we know just through using the metric system that if we have 1 kilogram, we have for every 1,000 grams. So another way of saying that is for every 1 kilogram, we have 1,000 grams. Okay, so if we were to see a ratio, we can create that fraction that we see there. Okay, so that's all we're doing there. Okay, well, let's get rid of that. Okay, so again, this is our conversion factor, but it's not really asking us for a conversion factor. It's saying, hey, you have 20,000 grams. Wrote that poorly. 1 second. Okay. You have 20,000 grams. Okay. And with that, we want you to tell us, or you need to figure out how many kilograms that is. Okay, so how do we do this using a conversion factor? Well, what we can do is we can multiply and use that multiplication with the conversion factor to cancel out the units we don't want, keep the units we want, and then do the math with the number part. Okay, and here's how that kind of looks. So when we have our 20,000, what we can do is we can kind of also pretend, or we can put that at the top of its own fraction, okay? And the way we do that is we essentially just say it's over 1, right? So if you think of the number, maybe a smaller number, something 10. As a fraction, 10 over 1 is 10, right? So just as a little refresher here, 10 over 1 is, well, that's 10 ones, right? So we can just say that's equal to 10, right? And that's all we did up there, right? What else can we do with fractions? Well, 1 over 2 means we have 1 of a possible 2, right? So we know that as half, right? Or 50%. But the reason I bring that up is just, again, to illustrate what fractions actually mean. Okay, right? So if I have 4 over 2, I actually have 2, of the things, right? So 10 over 1 is saying the same as 10, okay? Great. Okay, so we have that premise established now. So now that we have this equation, 20,000 grams over 1, invisa 1. I'm going to call it invisa 1 because we don't typically write that. What we can say is we can start cross-eliminating. Okay, so again, we're just going to do this with the numbers by themselves and then the units by themselves. Or we're going to separate the two when we start working through this, okay? So with this conversion factor, I made some choices, okay? I chose to put grams on the bottom. Now, if I wanted to, I could have put grams on the top and kilograms on the bottom. There's a very good reason why I didn't do that. And it's because I can use this tool that's coming up to eliminate the unwanted units, okay? So we're starting with units. So how can I do this? Well, what I have here on top is grams on top of grams, essentially, as I move across this equation. So I have grams on the top of grams, okay? And I can see that because once I go to collect all my terms across, this is going to happen. Maybe I'll do that. Here, let's do this. Okay. So if we were to multiply all this together and write it all together, it's going to look something like 20,000 20,000, and then if we have just the numbers again times 1, and that's all over top of, well, our invisa 1 times 1,000 is just, we could do that, 1,000. So that's all the number components. And then for our units, we have grams times kilograms, and we have grams on the bottom, okay? So again, we're just trying to separate the numbers from the units. So when we really look at this, we can, just like we were doing, what we can do with this is we can say gram over gram, okay? Well, anytime you have something over something, it just equals 1, right? And so anything times that is equal to whatever the thing is you multiplied it by, whatever number that happens to be. So when we're going to eliminate things, when we get one thing over another, if they're multiplied, we can get rid of them, okay? So again, I'm going to show you that as we go back here. So again, without doing this whole component here, although I did explain that, we're going to do a very similar thing. What we can do when we look at this equation set up as it is with the conversion factor with grams on the bottom, I chose that for my conversion factor because grams are on the top of what I'm trying to use, okay? We're trying to convert from, okay? So revisit this after we get to the end, and it'll make sense, okay? Or should make a bit more sense. Okay, so we have grams on the top, grams on the bottom. Again, we can cancel that out, okay? So again, grams on top, grams on the bottom as we're multiplying across. So eliminate that out. And now we're going to collect all the terms that we do have. Well, what do we still have? Well, we have 20,000 as our numerator, as our number. And that is when we go 20,000 times 1 is 20,000. So that's our number. On the bottom, we have our invisa 1 times 1,000. So all we have on the bottom is 1,000. And now we go through and collect all our remaining units. Well, we don't have grams. That's been crossed out. Oh, but we have kilograms here. So we can carry that through. We got kilograms. And then we can do some math here. Okay. Great. So we end up with 20,000 divided by 1,000 is, drum roll, 20. And our remaining units is kilogram. Okay, so that's the long way that we went from grams to get kilograms. Remember, that was the goal. That was what the question asked us to do. That's what we're working towards. But that's how and why we use a conversion factor. Yeah. Hopefully that might have explained a little bit more of something that you knew previously or not, or yeah. But again, now that you know this rule, we could do something very cool with it. For example, with this conversion factor, or any conversion factor, you can always do the opposite, right? So if we want to go from kilograms to grams, the real easy thing is we just flip the conversion factor. So now we have 1,000 grams for every 1 kilogram. And we do that because, again, in this hypothetical question, we were given kilograms as our units. Any number, let's say 10. 10 kilograms of our thing, whatever it happens to be, okay? So we take that 10 kilograms, again, this is over in Visa1, and we find out that as we multiply across, we're actually multiplying these two numbers. So now that becomes 10,000. We cross out our kilograms, so we don't have those anymore, but the only unit remaining is grams. So again, we just converted from kilograms to grams, the opposite of what we did here, where we went from grams to kilograms. Okay, so we'll do one more, and then the rest you can use Google and use like a conversion calculator to check the answers, and then obviously check them and do them yourselves. But let's take a little peek here at, let's do question number 3. Okay, so a non-metric to metric. Okay, it's a good life skill to have if you're ever dealing with the States or going there or driving there. Okay, so it tells you your conversion factor right away. And let's just move that up over here. So we're going to say for every 1 mile, we get 1.6 kilometers. Okay? Okay, great. So let's keep moving that forward. Alrighty, so what we can do with this is we want to know how many miles. So, and this helps too sometimes to write it down. How many miles? We want to convert that to kilometers. Okay, so right away, we know we're given kilometers. We're given 5 kilometers. So that's the unit we have to start with. So what do? We'll write that first. Okay, let's just do this. Okay. So I got 5 kilometers. That's what I'm starting with. Well, now let's haul in our conversion factor, which we have over here. Okay. So I'm going to say times 1 mile over top of, and let's keep it same color, 1.6 km. Okay, so we know those are the same units. What does that equal? Well, do follow the same rules, same everything that we had before. We have this on top and that on the bottom, so we can get rid of those units. And then we can just collect all of our terms. We'll start with the numbers. So 5 times 1 is 5. In Visa1 times 1.6 is 1.6. Next up, we have our units. The only one remaining is miles. That's miles. And then we can do the math, so then we want to keep simplifying the terms. So we do the math there. And so 5 divided by 1.6 is 3.1225, I think. But if you were to just write 3.1, that's fine. Carry the miles down, and there you go. That's it. Again, you could flip it around and do the same. Let's say we had 5 miles to start with. We want to times by or figure out what it is in miles. So again, if you notice, same 2 numbers for the conversion factors, just flip so that I can cross out the miles. This case, when I'm going across the top, move. Okay, this time when I'm going across the top, it's 5 times 1.6. So that equals 8. And and then on the bottom is 1, and then the only units left over is kilometers. And then when we simplify that, that's of course 8 equals 8 kilometers. See, it's okay to make mistakes. It'll happen. Okay, great. And that's it. So that's how that works. Okay, we're going to keep moseying on forward. Again, if you have any issues, all the questions, even the more weird ones at the bottom, it's all the same stuff at the end of the day. You're just applying the same rules with slightly different ways. Sometimes they take 2 or 3 steps, so you might have to convert multiple things across the way. But again, it's just reapplying the same rule multiple times, keeping track of what you're doing as you're going along and doing it stepwise, especially when you're starting out. Very, very important. Okay. It might seem like other people are doing 2 or 3 steps at a time, and they might be, but if you're just starting out again or relearning or learning, really do everything step by step. Be very clear with what you're writing out. It helps so much, and it also helps me if I need to help you. I can see where your thoughts are, or you yourself, you can go back and check your work, or your peers can look at your work and be like, it was just this one little thing here that set you awry. Okay, so it's really, really helpful to do that. Okay, algebra, next up. This is great stuff here. This is a very essential skill to have for success with the equation math part of this course, okay? Again, I'm going to pick... I've already done this video once, and there's some data issues, but I'm going to pick 2, maybe 3, okay? Let's start with... And then again, the rules are the same. They apply to all the equations. It's just a matter of going through it stepwise. You have all the answers on the next slide, I believe. So they're there for you. I circled the important steps that you'll see coming up here of what you want to move and work with. But yeah, it's good to work through and figure out why you're doing these moves and how you're doing them. Use peers, use the math lab, chat with me if you feel like you're really getting stuck, set up office hours, come visit me, whatever is going to work for you. Okay, so and or do all of the above. The more time you spend with all of this, the better. I would say a big warning or concern point when you really want to seek help, if you haven't already, would be definitely by the time you are given the practice midterm to do. If you're struggling with that and that information, that's a really, really kind of important time to really start seeking outside help and dedicating quite a bit of time to stuff. Okay, enough of that. On to actually doing the algebra. So why would we use algebra? What's the point? How is it helpful? Well, ultimately, a lot of physics is equations, and equations are just relationships. They're just ways to explain how different things relate to each other. And the beautiful, amazing thing about physics is the numbers and the variables interrelate to each other in a very consistent manner. Right? It's the physical properties of this world. They're not changing. Their interactions between each other all willy-nilly. It's like they're very particular in how they interact with each other. So that's the nice, beautiful thing about this. It also allows us to calculate for individual variables given information. Okay. So what do I mean by all this? Well, solving for an unknown is a very common thing algebra lets us do, and something very common and important for us to do in this class. So let's take a look at this first one, and hopefully you'll see what I mean. Okay, so we have let's start with number 1. Oh my goodness, that's not what I want. So we have 2. Let's go 2a equals B. Okay, so what is this all about? Well, what are we saying here really? Well, we're saying 2 multiplied by A gives us a product of B. Okay, So whatever a happens to be, or whatever value it is, when we double it, it becomes b, okay? And that's the relationships between these values. That's how they interact. So what can we do here? Well, the goal with all of these questions is try to isolate a, or get a by itself on one side of the equation. And it just as a bit of a refresher, we're going to do this by applying the opposite to what's occurring on one side of the equation and do it to both sides. And here's how and why we can do it. It's very similar to what we're doing with our converting of units. Okay, so I see that 2 is multiplied by a, so I'll want to divide. That's kind of the opposite operation, so divide by 2. But because I've done that to the left side of the equation, I want to do that to the right. So I divide by 2. So now moving on, like condensing terms and moving forward with all of this, what does this give us? Well, we can actually cancel all this out, okay? Now, why could we do that? Why did we just get rid of both of the 2's on the left? Well, if you think back to the earlier example I was giving, 2 over 2 equals 1, right? And so if we just write 1 here and we multiply it by a, what's 1 times a? Well, it's whatever a is. If a is a 5, it's 5. If a is 6, it's 6. So we can essentially just get rid of writing that altogether. Okay, pretty cool, huh? So now what do we do with that, though? That's the next question. Well, now we just kind of draw all our terms together. So we rewrite this on the next level just to keep all our thoughts and ideas and logic clear and ordered. And what do we get? We get 2b, and now we have this 2 here. Okay, and so that's our answer. That's how we isolate a. And why do we do that? Well, again, these letters represent concepts. They represent new variables and numbers. So for example, a could be acceleration. A could be apples. There's lots of different possibilities that we can use with a. They just simplify a concept or a variable and allow us to work with the equations this way, okay? And so if you're given a question in class that starts out like this and says, you know, we have the information we want for b is 12, or let's even go a bit, let's say b is 10. So you know from the question, the information that's given to you, b is 10. When we're first given this equation with 2a equals b, you know, that's all fine and well, but if we're trying to figure out how much a is, we can't do that math. It doesn't really work that way. So what we need to do again is get a by itself on one side of the equation, like we did here for the second step. And then from here, if we have this information, what we can actually do is plug 10 in to b, okay? So now what that term becomes is our a, which we solved for to isolate, equals 10 over 2. And we can do that math. 10 divided by 2 is 5. So essentially what we've said here is a equals 5. Okay. That was the messiest 5. Okay, so a equals 5. And we have our solution, okay? So a could be, again, acceleration, mass. It's just some variable that we happen to be looking for. And now we've got. And that's a really cool thing about physics is if we're given a whole slew of information, we can calculate something that we really didn't know or measure to start with. It's kind of wild. Okay, great. So that's 1. And we have a little bit of premise of how we start moving things around. And just as a reminder, you know, kind of opposing factors are plus minuses. You know, we have multiply and divides. The other one that comes up that we won't do in this component here, but you'll see it come up later in lab, just so you're not surprised, is something that's squared and then square rooted. So those are the opposing two operations for that. Okay. Okay. Pressing forward. Again, you can always come back to these, revisit them, figure them out, or more specifically, as we're moving forward, ask to see them how they're operated right in the equations that we're working with when we get there. Okay. Okay, so I'm going to do one more. Let's do number 9. I think that might be a good example. Okay, so number 9 on your sheet, what we have is, oh man, I really. Okay, so this will be the last one. A times, oh, where are we at? C. Okay, AC minus, let's do this one. Minus D equals B, right? Yeah. Okay, so you look at this, and again, our goal is to try to isolate A. Okay, same goal, same idea. But now we got two terms on the same side of the variable that we're looking for. Where do we start, right? And generally speaking, I like to start with whatever is easiest and cleanest to move over. And that's usually plus or minuses, okay? So if we're looking at this term, we see a minus. So what do? We do the opposite, right? So we add D to that side and we add D to this side, okay? Again, from there, what's minus 5 plus 5, or what's minus 10 plus 10? Well, it's 0, right? So we can get rid of those terms. Okay, so let's clean that up. What do we got so far? Our next steps, we're looking at AC equals B, and what color? Pink, yeah, plus D, okay? Great, awesome. And you should also note that this whole equation is just all letters. Letters aren't scary, intimidating, they're not confusing, they're just kind of like numbers that you don't actually calculate per se, okay? Okay, so here we are. What do we do next? Well, A has still got C beside it. So how do we get rid of that? Well, we divide, okay? So multiply, the opposite is divide. But how does that kind of look here? Well, usually you can just write it. Oh, I want to do it in red, sorry. Usually you can just write it like that. But if you're to really, really write it out, well, that's the easiest way to do it. And then the kind of tricky, or the catch part here, is on this other side, you can't just do it. You can't just divide C by B or D. You actually have to do the whole plus minus term. Okay, and that's because it's plus minus, or it's addition or subtraction. Okay, so that really helped us to move that over first, right? So again, from here, C over C, as we spoke about before, just 1, because they're multiplying, we can get rid of it. But on this side, we can't. So when we go to collect our terms again, our final answer, even though this was a big two-stepper, what we end up seeing is we have B plus D divided by C. And that's it. That's all it's done. So again, same thing. When you come across this time and time again, no matter how many variables are kicking around or divided, we just, again, start pulling terms over. Start with the easiest stuff to clean up, the ones that kind of have the least amount of terms attached to it. Start moving them out of the way, and whatever is easiest to get that working for you, okay? Question number 12 is maybe a little advanced from what you need to know, but again, having those tools in your toolbox will go a long way, okay? Okay, so yeah, as far as the algebra, like I said, you have your questions or answers here. I tried to circle where the cancellations were happening so that'd be a bit more clear for you. But just as a final brief note on approach, okay, with math, if you're really struggling, again, I keep saying it, I'll keep saying it throughout the first part of the course here in the semester, is really, really, really spend that time to understand what's going on, because these rules don't change by the end of the semester. They don't get easier. They just are what they are. So again, try not to get frustrated. You need to fail. You need to make mistakes in order to learn. Those are the exact moments where there's a learning opportunity there. And again, everyone's had different experiences in learning. They've all done it at different points in times in their life, with math, sorry, in particular. And again, just getting some of these fundamental components is really important, and trying and keep being persistent until you get your aha moment. Okay. Again, I'm very open to running office hours or small tutorials or whatever the case is. But yeah, again, reach out to your peers, reach out to the math lab, tutor groups, and myself for assistance. Okay. Okay. Well, hopefully that gives you a place to start. There's definitely more resources and materials that will generally be found on Blackboard, so feel free to go there and work away. Okay. Yeah, best of luck. Great first lecture. Next lecture we'll cover anatomy, and we'll get all your basis kind of covered there before we start pressing forward into the more physics-based biomechanics. Okay. Okay. Bye for now.